Domain and range. We're starting in Unit 2 with an introduction to what we call parent functions. But before we can talk about that, we need to discuss and review domain and range of functions. So there are actually three ways you can notate domain and range. The inequality notation you learned back in Algebra 1. We're learning interval and set builder in Algebra 2. So let's review the inequality notation. So when you had the inequality notation, you started off with the low number, the minimum number, and then you picked one of these symbols, less than or equal to. You had a variable in the middle. If it was domain, you used X. If it was range, you used Y. Then you had another set of symbols, and then you had the maximum number. Domain works left to right, and range works bottom to top. Domain is always your X's and range is always your Y's. Okay, so if you had a solid point on the graph, you used a less than or equal to. If you had an open point, an infinity, or a dashed line, you used if you had a solid circle or a solid line, you used a less than or equal to. If you had an open circle, a dashed line, or an infinity, you used a less than. So here's an example of what it would look like. So an example of from last year, it may have been 2 less than or equal to x less than 5. That could have been an example of some function's domain. We're going to take something new and we're going to do interval notation. So interval notation is probably the simplest way to notate domain and range. So first thing is interval notation looks like a coordinate point. So it looks like a point. Okay, now it's going to be the low number, comma, the high number. Again, min and max. You can have either a parenthesis or you can have a square bracket. And here's how you tell when to have which one. When you have the solid dot or a solid line, that is when you do these square brackets, either side. When you have the open circle, the dashed line, or the infinity, that's when you use your parentheses. So a square bracket means you can include that number. An open parenthesis means you are not allowed to include that number. So here's an example of what it may look like. I'm going to use the same numbers from the example in the blue inequality notation. So the way we can translate this blue inequality notation is we would have a 2, 5. So the low number is 2, the high number is 5. And on the 2, since this is a less than or equal to, that means we had a solid point. So that would be a bracket. On the 5, since this is a less than, that means we had an open point. So that would be a parenthesis. So this is what interval notation could look like. You can have both being brackets, you can have both being parentheses, you can have one of each, but this is what the inequality or the interval notation looks like for domain and range. Now finally, the set builder notation is very similar to inequality notation. So here's what it looks like. You have the curly braces to denote that this is a set of numbers. Then we put the variable that we're using. So if we're using domain, we'll put x here. If it's range, we'll put y. Then we have a vertical bar. This vertical bar means such that. And then after that, we put some inequalities. And then we close the set. So how this would read in English is this piece right here would read as the set of x's such that, and then you need a condition. And so over here, this part is the condition that must be true. Okay, and here's an example. So I'm going to use the blue inequality notation. So the way we would translate the inequality notation into set builder is we would have the curly brace, an x, the vertical bar, and then we would have the inequality, 2 less than or equal to x less than 5, and then close the curly braces. And here's how this would read. So this would read the set of x's such that 2 is less than or equal to x, which is less than 5. So if you have an x value that does not fit inside this condition, it is not in the set of these x's. That's basically what this means. This is a more mathematically correct way to use interval notation. These two are very closely related. Okay, so let's put this into practice. Let's do some examples. So we're just going to work with one dimension at a time. So for number one, this is just a horizontal axis. So this would technically be our x's because it's horizontal. So I'm going to put x up here somewhere. And we're going to write the domain of this in 3 ways. First, let's go back to the inequality that we're used to from Algebra 1. So the low number we have is -4. It is a solid circle, which means it's going to be less than or equal to. Because we're using x's, we're going to put an x. Now I need the high number. And so the high number is a -2, and it's a solid point, so we're going to say less than or equal to -2. This is what we are used to back in Algebra 1. Now let's talk about this in an Algebra 2 standpoint. Let's talk interval notation. So for the interval notation, it's the same graph, but it's actually simpler. You're going to take the low number of -4, comma, the high number of -2, and then we're going to decide, am I going to use a parenthesis or bracket? Well, for the -4, since it's a solid circle, we're going to use a bracket. And for -2 is also a solid circle, so we're going to use another bracket. And this is interval notation. That's it. It looks like a coordinate point. The low number first, then the high number, and then decide if it's a parenthesis or a bracket. Now, for set builder, we only have to tag on the extra mathematical piece to the inequality notation. So we're going to use the set of x such that, and then again, from -4, it's a solid circle, so less than or equal to x, all the way up to -2, and it's a solid point, so that's a less than or equal to -2. And there's our set builder. Let's try one that's vertical. So for this guy, since he's vertical, this would technically be y's. Since he's a vertical number line, this would be a y axis. And so let's do the inequality notation first. So again, the lowest number on a y-axis is actually the bottom first. Smallest numbers for y-axis is on the bottom. So their low number is -2. Now, this is an open circle, so we use less than. So this is because it's an open circle on that -2. Now we're going to put y in the center because it's the y-axis that we're working with. And then now I see that there's an arrow here. So what that tells me is that this shaded area will go all the way up to infinity. So that means my high value is infinity. Okay, now let's do the inequality notation. So for the inequality notation, we're still going to use the low value of -2. So -2 is the low, and the high value we already said was infinity. So now we have to decide parenthesis or brackets. So on the -2, it's an open circle, which means you cannot actually have the value of -2, which is why it's an open circle and not solid, which means we're going to use a parenthesis to represent the fact that I cannot actually take on -2. Infinity is an idea. So with infinity, this is an idea of the largest number that I could possibly think of. So infinity itself is not an actual value. It is not a number that you can take and substitute into an equation. Since infinity is not a physical value, you will never be able to actually hit infinity. So this is also an open parenthesis. Infinity is never going to have a bracket because you will never hit infinity. And now let's talk set builder. So with set builder, we're going to do the same thing that we did with inequality. We're going to use the little set bar. This time it's a y though, because it's up and down. And then we have the such that. So y such that, and now I need an inequality. Well, the low value is -2. Then we have less than y. And then we have this less than infinity thing. So with set builders, we don't really like to use infinities. So this is really all we have for set builder. But there's also a better way to do this way as well. The better way is when we put this y value in the front and the -2 in the back. So when we flip the order here, we also have to flip this inequality symbol to make sure that it goes the same way. So if we take a look, the large side was originally on y, and now the large side is also on y. So this is the correct inequality. These are the same thing, just in backwards orders. So set builders don't usually have infinities. Now let's look at number 3. Number 3 looks weird. So I have a shade. This is left to right again, so this is another x. But I'm missing a shade in between these 2 points of -2 and 2. We're missing a shaded piece. So when we do the inequality, we're going to have 2 separate inequalities. This is those compound inequalities that you may have heard of last year. So let's start with the left side. So let's work with just the left side only. The low value on the left side is -infinity because this will continue moving on forever. And then the high value on the left is -2. So we have -infinity less than x less than -2 because it's an open circle. Now, we don't like the infinity sides when there's jumps because there's a jump here. So we just really have this piece, x less than -2. That's the left side. On the right side, your low value is a 2. So 2 less than or equal to, because it's a solid point this time, x, and then this moves on to positive infinity on the right. So this is going to be less than infinity. So again, we don't like infinities when there's jumps. So we're just going to leave this as 2 less than or equal to x. And the way we finish this off is we put the word or in the middle. Because as long as you're in one of those shaded areas, you are in this graph's domain. You don't have to be in both. You just have to be either here or here. So that's why there's an or in the middle. Now let's see what this looks like when we have interval notation. So for interval notation, again, we're going to take it in pieces. We're going to look at the left side first. So for the left side, I have -infinity, which is going to be a parenthesis, -infinity all the way up to, comma, -2, which is an open point, so it's going to be an open parenthesis. With the interval notation, we use the U kind of like what this means is union. So we're putting together these 2 pieces. So I can have any value between -infinity to the -2, but also, so we're going to go on this side as well, may not be a parenthesis, sorry. Now we're going to look at the right-hand side. So our low value is a 2, our high value is infinity, and we need to figure out bracket or parentheses. So this 2 is a solid circle, so we're going to do a bracket. And infinities are always parentheses. So when you have a jump and you're using interval notation, you're going to put a U in between the 2 pieces to denote that those go together. And finally, let's talk set builder. So again, set builder is basically this guy, just fancier. So we have x such that x less than -2 or 2 less than or equal to x. And there's your set builder. So now that we've done one variable at a time, let's talk more about what you're actually going to see. These are more like graphs you're really going to have. So let's start with number 4. So number 4, we're going to write domain and range in 3 ways. Okay, I'm actually going to start with interval because I think interval is a lot simpler to do. So with interval notation, I'm going to use blue for domain. Domain is your x values. So I need from left to right, my furthest left to my furthest right. So here is the furthest left point, and that has an x value of -5. So we have -5 all the way up to. This guy is the furthest right, and that has an x value of 0. Let me fix my point. It's an open circle, so let's do an open circle down here. And so that x value is 0. Remember, we're doing domain. I want the x, not the y. And now let's go back and talk about brackets or parentheses. So the -5 was a solid point, so he's going to get a bracket. The 0 came from an open point, so he gets a parenthesis. And that would be your interval notation right there. And now let's talk in the inequality. So we're going to use the interval notation to help us with the inequality. So the low value is -5, and because it has a brace, we're going to do a less than or equal to. Those mean the same thing. Then we're going to have x in the middle because we're talking domain. And then our high value was a 0 with a parenthesis, so that means that's going to be a less than 0. And there's your inequality. And then finally, the set builder is just going to be the fancier version of the inequality. So we're going to have the brace, the x value such that -5 less than or equal to x less than 0. Now let's talk range. So range is your y values. Range is bottom to top, the furthest down to the furthest up. So now let's talk about the interval first. So for interval notation, the lowest point is this one, and this guy has a y value of -1. So we have -1, comma, and then now we need the high value. So the highest point, the furthest up this graph goes, is this open point. We want that guy's y value. So we have 1, 2, 3, 4. So it has a y value of 4. Now we get to decide bracket or parenthesis. So -1 came from a solid point, so he's going to be a bracket. 4 came from an open point, so he's going to be a parenthesis. And that is the range in interval notation. Let's translate that into inequality. So again, the low value is -1. Because -1 has a brace on it, a bracket, he's going to be less than or equal to. And then we use y this time because we're talking range. And then the 4 has a parenthesis, so he's less than 4. The interval is a lot simpler and has less to remember. And then the set builder is the fancy version of the inequality. So we're going to have the set of y's such that, and then we're just going to use this inequality again. -1 less than or equal to y less than 4. And then close your set. Let's try one more together. So again, let's start with domain, and I like to start with interval because intervals are simpler than inequalities. So with domain, this is the furthest left to the furthest right. Well, if we look at this graph, I see that on the left side, I end up with an arrow. That arrow does not stop right here at -1. Arrows tell us that this graph is going to move on in that direction forever. So this arrow actually says two directions. This arrow goes up and he moves left. But we're talking about domain, so it's the left that I care about. So he's moving left forever, and those x's are negative, so we call that negative infinity. So the smallest value is negative infinity, comma. The highest value, the furthest right, is, again, I hit another arrow, which means I have another two directions. And we have up and we have right. And if I go right forever, that's a positive infinity. So my interval notation is negative infinity, comma, positive infinity. And since both sides are infinity, infinities are always defaulted as parentheses. Now let's translate that to inequalities. So our low value is a negative infinity. A parenthesis means less than. We use x for the center. Then we're going to use a less than because of the parenthesis and a positive infinity on the right. Now, the infinities on both ends make our set builder look even more mathy. So we have the set of x's such that. Now, we don't like infinities in set builder, but I have infinities on both ends. So when you have infinities on both ends, remember, this means all real numbers. And there's a symbol that we use for all real numbers, and it's the double barred R. So we say x such that x, and then we do a little e. What this means is an element of. So x such that x is an element of the all real numbers. There are sets of numbers, and all real numbers is a set. So the way we read this is the set of x's such that x is an element of the all real numbers. When you have infinities on both ends, your domain or range is all real numbers. Now let's talk range. So range is your y's, which is bottom to top. And again, we're going to start with interval. So the lowest this graph goes, the furthest to the bottom, is right here on the x-axis. Well, both of these points have the same y value. Their y value is 0. Then the highest they go, well, this side goes up forever, this side goes up forever, and this stops right here at about 5.2. Okay, 5.2 is not the highest because these arrows will overtake that little hump. So the highest this goes is actually positive infinity. I need the highest point of the entire graph. So on the 0, these are solid lines. So since this graph is made up of solid lines, we need a bracket on 0. And infinities are always parentheses. Now let's translate that to an inequality. So we have a low value of 0, less than or equal to, because of the bracket, a y for range, and then the infinity is a less than infinity. And then finally translating this to set builder. So we have the set of y's such that 0 less than or equal to y, and then I don't want the infinity side. Now remember, we can write that even better. We're going to keep the front part, and we're going to flip-flop this entire thing. So we have y, the less than flips around also to a greater than, and then 0. We like our variables in the front, if at all possible. So I would like you to see if you can try this example here. So this will be example 6. See if you can get example 6 with the domain and range in each notation to the right. This is what you should have come up with for a solution. And then let's do this last one together. So for example 7, I'm going to help you with the interval notation, and then you guys are going to get the inequality and the set builder by yourself. So with domain, we want to start with the furthest left to the furthest right. So the furthest left is this coordinate point here, that open circle, and that x value is -5. So we have -5, comma. The furthest right is this solid point at a +5 of an x. So on the -5, an open circle gets a parenthesis, and the +5 is a closed circle that gets a bracket. Now range, this is the weird one. So we have bottom to top. So the lowest this goes is actually both of these points. Both of these points have a 2, -2, as their y value. But one is open and one is closed. So the question is, what do we use? Bracket or parenthesis? Well, let's think. An open circle means I am not allowed to have this value. So over here, I am not allowed to have -2. But over here, I am. And so the overall range means I can have -2 somewhere. So since there's a solid point on this y value of -2, the solid point wins. The solid point kind of fills in the open point. And then the high value is right here, this flat part of this graph, and that has a y value of 2. And it's a solid line, which also means they get a solid bracket. Pause the video, see if you can get the domain and range and inequality and set builder. And here's what you should have had for your solution.